All right. Hypothesis testing is built around rejecting or failing to reject the null hypothesis. That is, we do not reject the null hypothesis unless we have strong evidence. But what does strong evidence really mean? It would be helpful to quantify that strength of the evidence against a null hypothesis. So, in the story we had at the beginning of this lesson, the professor was trying to determine the truthfulness of his students. He determined that by chance alone, and those are 3 key words there, by chance alone, the probability that all 4 students would choose the same tire was less than 2%. That suggests that the students were not just guessing. So when results like these are inconsistent with the null hypothesis, we reject the null hypothesis in favor of the alternative. So here the professor concluded that students were not lying. So this 2 in 100 chance, this is what we call a p-value. And essentially it's the probability quantifying the strength of the evidence against the null hypothesis and in favor of the alternative. Now, to find a p-value, we begin to first assume the null hypothesis is true, and then we want to see what random chance looks like. So we want to determine what the distribution of our point estimate will look like by chance alone. Once we have that distribution, we locate the point estimate and then determine the proportion of this distribution that is at least as favorable to the alternative as our current data set. Now, if our alternative happened to be less than, a proportion less than whatever the null value is, then we're looking at this kind of a graph. The middle of the graph is always going to be the null value. So the null value is always going to be in the middle of these distributions. We locate what the point estimate is, and then everything that's above it and away from the center, so that the yellow shaded part right here, this is the p-value. The p-value is basically the proportion of the null distribution that is above the point estimate or farther away from the null value. Now, if we're finding p-values from right tails, so this would be a situation where the alternative is the parameter is greater than whatever the null value is. It's pretty much the same. Again, the null value is always in the middle. We locate where the point estimate is. In this case, the point estimate is going to be larger than the null value. And then everything above it and away from the center is the p-value. That proportion is the p-value. So the p-value is the proportion of this null distribution that is above the point estimate or farther away from the null value. For our class, we're going to focus on two-tailed test, beginning with the next lesson, or I guess lesson 20. Two-tailed tests occur when the alternative hypothesis is set to the parameter not equal to the null value. So in this case, what will happen is the p-value will be a proportion of both tails. So we're really looking for the left tail and the right tail. Typically, we find the p-values before. We figure out the probability for the p-value for one tail, and then we multiply by 2. So when we're doing two tails, again, this is going to be the most common. Well, this is pretty much what we're going to be doing from here on. The middle will be the null value, and then the point estimate will be on either side, left or right. It's going to be at the edge of one of those. And then the p-value, the proportion of the null distribution that is above the point estimate or farther away from the null value. So it's just going to be the sum total of those two tails.